Hello students. Today we will cover the basic aspects of the unit of matter and whenever we hear about the term matter, we know that matter is the basic physical material of the universe. So it is anything that has mass or it occupies a space. And whenever we observe whatever materials in this world, they are made up of matter. So whenever every matter is composed of either elements, compounds or mixtures. So elements is a set substance which has the same type of atoms. And what are atoms? Now, atoms is the most infinitesimally building blocks of matter. And it contains again protons, neutrons and electrons and other subatomic particles, which we'll go through not maybe in this lesson but of course in this course. And what is molecules? Now, molecules is a stable form of matter. So it is a stable unit of matter. So a molecule may be composed of either one atom or more than one atom. So for example, if you say that any inert gas like helium or argon or xenon or krypton, they are composed of only one atom. So in this case, the inert gas, the atoms and the molecules are the same. But mostly, apart from inert gases, the molecules are made up of either two or more than two two atoms. For example, oxygen. If you take an oxygen, so it is made up of O2. So two atoms of oxygen makes one molecule of oxygen. Similarly, two atoms of hydrogen makes one molecule of hydrogen. So what is the difference between basic atoms and molecules? Atoms may not be stable, but molecules are always stable, which we can find in this universe. Okay. Now we will start off the atomic and molecular perspective of the chemistry. So if you see here, for example, I'm taking these three spheres, the white one for hydrogen, red one for oxygen and black one for carbon. And if you see for oxygen, for making the oxygen molecule, it will be diatomic, as just now I told you. So it is O2. So two atoms of oxygen makes one molecule of oxygen. Similarly, if you take one molecule of water, so it's a molecule of water and it is made up of one atom of oxygen and two atoms of hydrogen. This is just revision. You already know these things maybe.
So this carbon dioxide molecule has one carbon atom and two oxygen atoms. And similarly, if you see here the ethanol, which is C2H5 and OH, where OH is the radical or group that is attached. So it is C2, that is two carbon atom. H5 means 5 hydrogen atoms. Maybe some hydrogens are shadowed by the other. And the radical group contains one oxygen atom and one hydrogen atom. So whenever you think of a molecule, the purpose of this particular slide is that whenever you think of a molecule, whenever you try to think of the molecular perspective of that particular element or that particular compound or that particular mixture. So this will help you to understand not only chemistry better, but also the universe. In this universe, the reactions that are happening in our day-to-day life, you can visualize and understand those better. So try to understand their molecular perspective. Similarly, this is an example of aspirin. Aspirin, you know, is a medicine or a drug which is used by in many cases in order to thin the blood. That is it. Whenever some blood clotting happens, we give the aspirin drugs are given to reduce the clot. So this is also the molecular basis of the aspirin, which is made up of carbon, hydrogen, oxygen. Okay. So why you study the chemistry? Whenever ask these questions whenever you are studying chemistry to any particular lesson, either in school or in your home or here, anywhere. So ask yourself, why are you studying? So I've tried to relate only a few aspects of chemistry in this slide. So if you see, chemistry is used in to understand energy aspect better. For example, whenever you see a solar panel, so solar panels are nothing but they are the what do you say, the composed of specifically treated silicon. So it is again an element. Silicon, you know that it is an element. So similarly, whenever you think of technology, so this is just an example, like if you have heard of OLEDs, that is organic light emitting diodes. So they are used in the high-end cell phone, tablet or television displays. So this is again a chemical, okay? And similarly for drug industry or medicine, nowadays you must be knowing that a lot of vaccinations research are going on. So that is also a chemistry. You have to understand the drug or the chemical aspect of that particular drug and its effect on the body. So again, the biochemistry aspects, this is just an example. The flash of the firefly results from the chemical reaction. So you see that the chemistry is central to our understanding of the world around us. It's very, very important. Now coming to the classification of matter, you already know that there are basic 3 states of matter, that is a solid, liquid and gas. Also there are 2 more states of matter that has been discovered, that is the plasma and the Bose-Einstein molecules. So, but we will not discuss much about those 2 extra states of matter. We will be limited to only for these 3 basic states of matter for the current lesson. So whenever you think of the 3 states of matter, you can think of the molecular perspective, as I told you before. So in case of solid, the molecules are tightly stacked. In case of liquid, it is slightly tightly stacked, and hence they take the shape of the container. They don't have a specific shape. And the gases, they are not at all stacked. They are free, and hence they have neither a specific shape nor a volume. And whenever you think of the molecular attraction point of view, that is the highest molecular attraction, intermolecular attraction is in case of solid, and then it is liquid, and the lowest attraction, intermolecular attraction, is in the case of gases. So now matter classification can be also based on whether it is pure or it is impure. So whenever you are thinking of pure state of matter, they are composed of either elements or compounds, okay? And whenever it is impure, you can guess now, it is the mixtures. And mixtures again can be categorized into homogeneous or heterogeneous and so on. So this is the basic mind map. So whenever you see a matter, you have to ask to yourself, I've tried to draw this mind map for you. And whether it is homogeneous or heterogeneous, ask it to yourself. And then if it is homogeneous, for example, does it have a variable composition? If it's yes, then it is a homogeneous mixture or a solution. And if no, then it's a pure substance, right? And if it's a pure substance, then again it has 2 categories, like whether it is, if it's yes, it's a pure substance. Does it contain more than one kind of atom? Then it is, if yes, then compound, obviously. And if all the atoms are same, for example, then it is an element. So you can draw this mind map for your reference in your notebook, which can be helpful for you in the future. Okay, now I want to visualize some concepts. For example, this is the question, this set of reaction. And the question is that which of the chemical reactions represent a chemical change. So pause the video and observe these 2 sets of diagrams and think that which one is a chemical change and which one is a physical change. Now the answer to this question is that this one is a physical change. The A is a physical change. Why? Because if you look into the diagram very carefully, this is composed of the red balls and the white balls, okay? And they are the molecules of which are made up of 2 types of elements, okay? So this is a compound. Why? Because this is a pure substance. There is no thing that is randomly mixed, okay? So and what type of product is formed. So this side is the reactant and this side is the product. So what type of the product is formed? The intermolecular distance between the molecules have increased, but the chemical composition is the same. So the element, the molecules has not changed its chemical property. And now if you see in the second case, it has changed its chemical property. Why? Because if you see that the red and the white spheres have disintegrated or decomposed from each other, and they have formed discrete molecules. So the two red ones and two white ones. So this one is second one is a chemical change. Okay. Now I want to discuss some aspects of energy, because all the objects in this universe is made up of matter, as you know, but matter alone is not enough to describe the behavior of the world around us. So we need to consider the factor of energy, which is defined as the capacity to do work or the transferring the heat. And what is work? Now, work is the energy transferred when a force exerted on an object causes an displacement of the object. I will come to the basic formula here. Work is equal to force into displacement. Okay, so it is affected by two of these factors. Now, the third type of energy is the heat. So, the heat is the energy used to cause the temperature of an object to increase. Okay. So now I've given you two examples here. For example, this is a player who work done by the player on the ball to make the ball move. So the work is the energy used to cause an object to move against an opposing force. So here the motion of the ball and the motion of the player are opposite to each other, right? And hence there is a requirement of an energy by the player to change the direction of the ball. So if you can see that there is a mixing of chemistry and physics here. Okay. And in this case, the second diagram, if you can see, the heat is energy used to increase the temperature of an object. So and this is also a form of energy. Okay. Some more types of energy I think that we need to discuss are the potential energy, whose formula is mgh, and here the m is the mass, g is the acceleration due to gravity, which is fixed, that is in case of earth it is 9.8 meter per second square, and h is the height at which the object is there. Another form of energy is the kinetic energy. You may be knowing this formula, it's very common, half into mv square, where m is the mass of the object and v is the velocity or speed. In this case it will be the same, though mass and velocity and speed are not same. One is scalar quantity and one is vector quantity. You may have learnt in the physics subject. But here if we see that both have the unit of meter per second square. So it's the kinetic energy is half mv square, and it's the energy due to the motion of the object. The third type of energy that I think that you need to know is the chemical energy. So the chemical energy is released when the bonds between the atoms are formed and consumed when the bonds between the atoms are broken. So whenever their chemical reaction is happening, this type of energy is very, very important. Okay. Now, this is an example where you can see that in case of the, for example, a cyclist is moving downhill. So whenever the cyclist is standing uphill, it has the highest potential energy. Why? Because it has the maximum height. So if this is the level, this is the zero level or ground level, here it is the maximum height, and hence if we see the formula of potential energy, it has the maximum potential energy and zero kinetic energy, because here the cyclist is not moving, the velocity will be zero, and if the velocity will be zero, though it has a mass, the kinetic energy will be 0. So this is an unique example where you can compare both the potential and the kinetic energy, and you can see the difference, how they work together. So at both of them, it's very important to remember that the total energy is conserved. That is the law, due to the law of conservation of energy. So we'll understand through these through more numericals, and we'll see. So before going further, I want to pose one question in front of you. You may have used rechargeable batteries. So the question is about the rechargeable batteries, and the question is, what happens to the chemical energy of a nickel metal hydride battery as it is recharged? So you may have used the rechargeable battery. It looks somewhat like this, and you can reuse these batteries if you recharge them. So what happens to the chemical energy? So I want to pause the video and think before I give you the answer to this particular question. So the answer to this question is, if you think that the chemical is actually constant, not changing, so it is nickel hydride only, right? We are not adding the chemical within the battery, and neither we are taking out something, only we are charging it, and the charging process results in creation of ions, separating of ions. So what happens here is, during the process of recharging, the ions get deposited, the positive and to the respective positive and negative electrodes, okay, and this results in increasing the chemical potential energy. So this is somewhat we can think that but there is neither a new chemical formed, but of course there are ions formed, and hence there is an increase in chemical potential energy. Okay, the last part of today's class will be the units of measurement I will want to discuss, and it's very important that many properties of matter are quantitative, that is associated with numbers, right? When a number represents a measured quantity, the units of that quantity must be specified. We know this. And the units used for scientific measurements are those of the metric systems. So you may have heard about the term SI unit. I will specify this table, and I want you to note it down on your notebook so that you can refer throughout the course. So it's important, it's very important table. For example, I will just mention like this is the physical quantity column, this is the name of the unit, and this is the abbreviation. For example, for the length, the SI unit is meter and the symbol is m, small m. For mass, it's kg. For temperature, it's Kelvin, though for temperature all many other units are very common like Fahrenheit or centigrade. But the SI unit, whenever we consider, it is the Kelvin, and the symbol is capital K. For time, it's a second, that is symbol is small s. For amount of substance, it's a mole. The concept we will learn not today but throughout the course. It's very important, the mole concept. And for electric current, it's ampere, and for luminous intensity, it is candela. This table is also very important, which may be used for the numerical purpose, and I want you to note it down in a notebook. For example, it's referred to as peta, that is 10 to the power 15, and whenever we think of 10 to the power minus 15, it is femto. Okay, so it's like kilo, we know that 10 to the power 3, and it is respect to the basic standard. For example, it's for the watt. 1 kilowatt is 1 into 10 to the power 3 watts. Similarly, 1 kilometer is 1 into 10 to the power 3 meters, right? 1 kg or kilogram is 1 into 10 to the power 3 grams. So here we have to consider the basic SI unit, and this is just an example with respect to the watt, but you can use it with respect to the length, you can use it with respect to the amount or quantity of material or luminous intensity or anything. But these are the prefixes which are very important, and you need to remember it, like the peta, tera, giga, mega, kilo, it's very common, deci, centi, milli, micro, nano, pico, femto, atto, and septo. So yes, note it down in your notebook.